Hello again and welcome. In this video, we're going to be working on dividing rational expressions. Okay, remember, rational expression is just code for fraction. And when we divide fractions, remember the old saying, you're going to keep, change, flip. So you're going to keep the first fraction the way it is, change division to multiplication, and flip the second fraction. This is the same thing with you have rational expressions. Okay, and actually your first step should always be just rewriting the problem as keep, change, flip so that you know what you're looking at and you don't get things confused. So for number one, what I'm going to do is I'm going to keep, change, flip. I'm going to rewrite as my first step. So I'm going to keep the first one times 6 over 7b. Again, it would be really easy to simplify that 4 over 8, but just rewrite it the first step and then start your math after the rewrite. What you don't want to do is you don't want to look at a problem and go, oh, I got this, and get so caught up in the simplifying that you forget to flip that second fraction. But now that we have flipped things, we can go ahead and simplify. So this will be a 1/2, and then the 6 and the 2 will simplify, and that'll be a 3, which means my final answer will be 3 over 7b. All right, let's go to the next one. I'm going to rewrite 2 over 10 times 5 over 6n. Okay, I'm going to simplify across first. So the 5 and the 10, this is going to be a 1. This will be a 2. My 2 over 2 is going to simplify and just be the 1, which means my final answer is 1 over 6n. All right, let's get some bigger problems. Down here on number 3, first step, you're going to rewrite. Now remember, don't get scared off by the expressions. The skill is the exact same. Stay confident in what you're doing. Okay, now nice and conveniently, it has 3v minus 7 and 3v minus 7. So I can just go ahead and cancel those out. Then I have an 8 in my numerator and an 8 in my denominator. So I'm going to simplify that. And then I am left with, in my numerator, v plus 8 and 2v. And that would be your final answer. You cannot simplify the v's because the numerator is wrapped up in addition. Now you might be noticing the similarity between this video and the multiplication video. You're not seeing things. As I'm doing this, I'm just keep change flipping, I'm rewriting. You're not seeing things. This video, this whole section has a lot of repeat skills. Okay, so you're reusing a lot of things, which is the nice thing about math. All right, so all I did was flip things over and rewrite, and now I'm going to simplify. So I have the k plus 4 and the k plus 4 will go away. And then I see this k minus 7 and this negative k plus 7. So I'm actually going to pull that off to the side. I'll do it in red so you can see it. I have a negative k plus 7. Whenever you want to change the sign, you factor out a negative 1. So I'm going to factor out a negative 1 and see if it ends up matching. And it does. I now have a k minus 7 on the inside, and that will work. So I can actually write my numerator as negative 1 times k minus 7, which means my k minus 7s will simplify, and I'm left with this negative 1. All right, don't forget about the negative 1. Nothing else simplifies, so my answer is negative k minus 9 over k minus 8. Or you could write it as negative k plus 9 over k minus 8 if you distributed the negative to the numerator. Either answer is correct. Okay, let's do number 5. Now in number 5, we're seeing 2 trinomials, so that means we're going to have to factor. So let's go ahead and do that. Keep, change, flip though first. That's always the first step, is rewriting. If If you can do it both in one step, that's awesome, but I'm just going to do it one step at a time so that we don't confuse people. Okay, now I'm going to factor, so I have m plus 8 in my numerator. This is going to be m plus 8, m minus 6 times, and this is going to be m minus 6, m minus 6. And there we go. The m's plus 8's will simplify, one of the m minus 6's will simplify, and I am left with m minus 6 over m plus 3, and that is as far as it goes. Let's go on to number 6. Keep, change, flip as your first step always. So now as I'm looking at it, I don't have a trinomial to factor, but I do have this really odd looking denominator, which, as I'm thinking, reminds me of GCF. So I'm going to look and check for a GCF, and there is one. So I'm going to pull a GCF out. Don't forget about your GCFs. So I can pull an 8b squared out, which means I'm left with a b plus 6 on the inside. 8b squared and 8b squared will simplify, and that's it. So now I have 5b squared over b minus 10, b plus 6 as my final answer. Okay, and last two. Again, as you're doing this, I'm going to do a GCF out of this first one just because I can see it. Don't feel the need to do a lot of steps all at once. The important thing is that this first step is primarily your keep, change, flip. That way you don't forget about it. Also, as I'm factoring, please do not forget about your difference of two squares. It's not on this worksheet, but it definitely is a favorite of math teachers and math problems to have a difference of two squares as one of your factors, simply because it is often forgotten about. You don't want to get caught by that old trick, so please make sure you don't forget about them. Okay, now that I have factored, I'm going to go ahead and I'm going to cancel out. So I have an r minus 4, the r minus 4, r minus 10, r minus 10, and that's it. R minus 6, r minus 8 over 5r. And now number 8. By now, you should be feeling pretty good about these. I'm going to start combining steps. You can follow along. Again, keep, change, flip is the most important part, but you can usually factor out that first fraction. Okay, first fraction is the same. If you can't do it all in one step, that's totally fine. Just do it in two different steps. Actually, bit of a math error there. You may have already caught it, but this should be a 3. 36 divided by 12 is not 4. All right. Either way, this will completely cancel with the bottom. P plus 2 will simplify, and therefore the only thing I'm left with in my numerator, or at all, is my 6p. Now, the last two problems I want to talk about are examples that you may not see a whole lot in algebra, but you will definitely see them all the time in Algebra 2. Now, these two problems, you set them up the way we've been doing them. Okay, you would rewrite it as z squared minus 19z. Okay, minus 11, and then you would keep, change, flip, and you would do z plus 8. But if you're looking at that first trinomial and you're trying to factor that in your head, you realize that there are no two numbers that multiply to negative 11 and add to negative 19. Okay, that problem cannot be factored easily. Nor if you were to plug it into the quadratic equation, would you get a nicer number. Okay, so when simplifying and the way we've been doing it doesn't work, we again fall back on old skills. And the old skill we're falling back on is long division. So as a reminder, if I was going to divide, let's go 102 by 5. So 102 divided by 5. Okay, I would rewrite that as 5 divided by 102. And I would ask myself, how many times is 5 going to 1? It doesn't. So I'd move on. How many times is 5 going to 10? Twice. So 2 times 5 would be 10. That would, when we subtract, that would cancel out. Bring down my 2, and I would have a remainder of 2. So you could write this as 2 plus 2 divided by 5 as your final answer. Okay, this may be ringing some bells from algebra back when you were in middle school. It may not be. But this is the skill we'll be using with these polynomials. Okay, because what we can do with numbers, we can also do with polynomials. So because this fraction or expression does not simplify the way the others did, I am going to rewrite it as a long division problem. And I'm going to need more room than that. All right, so the first thing you got to do is rewrite. That step has not changed. Now, when I'm doing long division, just like in the other problem, you're going to look at the first term and the first term. So I'm looking at z and z squared. All right, I'm going to ask myself, what do I have to multiply by z to get z squared? The answer to that is another z. Okay, so now I'm going to multiply and distribute z to both of my terms and write them underneath. So z times z is z squared. Z times 8 is a positive 8z. So far, so good. Now I'm going to subtract. The z squares will cancel out nicely, and now I have negative 19z minus 8. Negative minus a number. We're still going to have a negative number, and that's going to be a negative 27z. Now I'm going to bring down my negative 11, and there it is. Okay, so I'm still looking at my first term, and now I'm looking at negative 27z. So what times z will make it negative 27z? Answer, negative 27. So negative 27 times z will give me a negative 27z, as planned. And then negative 27 times 8 is a negative 216. I'm going to subtract. The negative 27 z's will cancel out. And now I have negative 11 minus a negative 216. Now this might be a little hard to see, so I'll rewrite it over here. You have negative 11 minus a negative 216. Okay, remember, whenever you have that negative minus a negative, it ends up being addition. So now I have 11 plus 2, negative 11 plus 216, which is going to be a positive 205. Okay, and now I'm done. But to rewrite my answer, it would be z minus 27 plus, since this number 205 is positive, 205 divided by z plus 8. Okay, this last little fraction is known as the remainder, and you write it as a fraction the same way you would leave a simplified fraction alone. Okay, you cannot divide it any further and still get a neat number. So whenever you don't get a neat number in math, you just leave it as a fraction to stay accurate. Okay. Let's go on to the other one, number 10. Same principle. Okay, if you're looking at this, you'll notice that there is no way you can factor that trinomial. But it is worth pointing out that you can do this long division with any kind of polynomial, whether you can factor it or not. Okay, the long division will work in all cases. It just maybe isn't your first thoughts. We don't teach it until, right now. Okay, and here we go. So again, looking at my first term and my first term. So what times x will give me 2x squared? And that's going to be 2x. Now I'll distribute to both of my terms. So 2x times x will give me 2x squared, as planned. And 2x times negative 7 will give me a negative 14x. Okay, this will turn into addition. And now I have 5x right here. So my next, and then bring down the negative 35. So my next question now is what times x will give me 5x? Well, that's 5, so plus 5. 5 times x is 5x. 5 times negative 7 is negative 35. And both of these will cancel out nicely with the remainder of 0. So this actually divides completely, which means my answer to the problem is just 2x plus 5. Okay, so whenever you have a remainder, you're going to write it as a fraction and tag it on to the end with whatever this sign is. Okay, our remainder's sign was positive, therefore it's going to be added on. If the remainder was negative, you would subtract it. If it divides completely, then you don't have to worry about a remainder. Let me know if you have any questions, and I'll see you next time.